Hello friends, so we have come across to the point at deadlock avoidance. Okay, so the first thing is, what is deadlock avoidance? So deadlock avoidance is nothing but a method for avoiding deadlock. As the name is suggesting, avoidance, that means something has to be avoided, and what has to be avoided? Yes, deadlock. Okay, so uh, uh, what is the different thing in avoiding deadlock in comparing to preventing deadlock is that a method for avoiding deadlocks is required additional information about how resources are to be allocated. Okay, so I mean, a deadlock avoidance algorithm dynamically examines the resource allocation state of to ensure that circular weight condition can never exist. Okay, the resource allocation state is defined by number of available resources, the allocated resources, and the maximum demand of process. So this algorithm will take order n square of time, where n is the number of process. So what is the next thing? The next thing is safe state. Then what is the safe state and what is the safe sequence? A safe state is a state if the system can allocate resources to each process in some order, still avoid a deadlock. Okay, more formally, a system is in safe state only if there exists a safe sequence. So how we can find safe sequence? And the concept comes Banker's algorithm. Okay, and this is the most important topic for GATE, guys. So the Banker's algorithm. What is Banker algorithm? Let's see. So the Banker algorithm says that resource allocation graph algorithm that we have studied in our previous video. If you have not seen that video, go to the playlist, go to the operating system, then go to the deadlock and see that video. I will try to navigate the link at the last of this video so that you can easily find that video. Okay, so come to this point. So resource allocation graph is not applicable for multiple instance of resources. Okay, so the deadlock avoidance algorithm that we describe next is applicable to such system, but is less efficient than resource allocation graph scheme. So the algorithm is commonly known as Banker's algorithm. And what is the Banker algorithm? So I am not going to the steps of and the coding of the algorithm, because that will take quite time and it will be quite complex and is not asked in any university exam or in any GATE paper so far. So what is the important thing? The important thing is doing the questions, because it is asked in university exams as well as GATE. So this is the question that I am going to do, but this is the thing that I want to tell you guys, that in this question there are three metrics, basically: allocation matrix that will tell the allocation of the resources, maximum matrix that will tell the maximum of resources available, and available matrix. And the next thing is what is the next thing? Next thing is need matrix. So need matrix is what? Maximum matrix minus allocation matrix. So this is not mentioned here, so I am just writing. You guys can see that need equal to maximum minus allocation. Okay, so we will first find the need matrix, then we will check whether the request the need is less than or equal to available. It means the available should be more than the need matrix, and then we will check these steps. So I am not going in so complex way. I'm just doing this questions. Okay, this question, and I'm trying to find the safe sequence. If the safe sequence exists, there is no deadlock. If not, then the system will be in some unsafe state. Okay, so what I can do is wait. Okay, I'm going to do this question. I think you must have written this question. So first I am going to find the need matrix. So guys, just note down the need matrix. Okay. So need is equal to maximum minus allocation. Okay, that I have told you guys. So what I am going to do is I am just I just want a new page. Let me see whether I can find or not. So okay. Adding a plan. Wait. Guys, wait a minute. Yeah. So what I am going to do is I am going to write need matrix minus allocation. Okay, so I hope you guys understand. So what I am going to write is I am just subtracting. This is equal to okay. So need matrix is equal to max minus allocation, and the max matrix that I am going to see is this thing is 0 1 0 for this thing 0 1 0 7 5 3. So what will be my max matrix? So I am just calculating here. So the max matrix will be 7 minus 0, that is 7. Okay, so I am just writing need matrix. 5 minus 1, that is 4. 3 minus 0, that is 2. 3 minus 2, that is 1. 2 minus 0, that is 2. 2 minus 0, that is 2. 9 minus 3, that is I think 6. 0 0, and 2 minus 2 is 0. 2 minus 1 is 1. 2 minus 1 is 1. 4 minus 0 is 4. 3 minus 0 is 3. 3 minus 0. So this is the need matrix. Now we will check whether the available resource, that means the availability of resource, and the need, whether need is less than or equal to available, or available is greater than or equal to need in some cases. So let's check this case. Okay, so available is 3, it wants 1. Available is 3, it is wanting 2. Available is 2, it is wanting 2. So yes, this will be satisfied. Let's check this thing. Okay, so available is 3, yes. Needing only 0, 3, needing only 1, 2 only. So this will also satisfy. What we will do, we will allocate need is 0 1 1. So what we will do, we will allocate 0 1 1. Then the available resources will be 3 3 2, and it will be allocated. So it will be like these resources will be, this process will complete its allocation. Need will be satisfied, and these resources will be free. So it will be 2 1 1. These resources will be free, because why? Because we are sending these resources to this process, and this process will complete its work, and after completing, these resources will be free, and the process, the available resources will be 3 3 2 plus 2 1 1. That means 3 4 5. Now whether this can complete anyone's desire, so let's check this. So yeah, this is alright, here alright, here alright. So yes, we can complete this thing. So the available resources after completing this process will be 5 4 5, and the sequence will be, first we executed P3, then we executed P4. Okay, now 5 4 5, whether this can this can complete anything. Let's see. Okay, so what we can see is just a 1 minute. What we can see is 545. Okay, 545. Okay, after executing P4. So the need of the second P1 is 122. Yeah, this will be complete. So it will 0200. Then it will become 745, and the next process will be P1. And whether now let's check this can complete. Yeah, P2 can complete also. So 302 will also be there, so it will be 7, 4 and 10. Okay, yeah. So after that we can run P2, then we can run P0. So there can be multiple sequence here, we can also run P1 first, then P3, then P4, then P2, then P0. So you have to just try permutation and combination to find the safe sequence, and this is a safe sequence. Okay, so this is a safe sequence. So what we did, we just first find out yeah, we found a need matrix. Then the need matrix will be max minus allocation, so it will be the need matrix. After finding need matrix, I am writing just one step, 7, 4, 3. We check this with the need matrix. So if it satisfies, then we add these resources to available resources, because when the process completes its work, these allocated resources will be free. Okay, so we are just writing it, and then 4, 3, 1. Okay, 4, 3, 1. So you just check the calculation. We can make mistakes in calculation. So just keep checking the calculation again and again, and then try to figure out which need will be completed. If the need is completed, add the resources in the available resource. Like I am adding this 3 plus, if I am completing this need, then 2, 1, 1, then it will be 5, 4, 3, and same I will repeat the process. So my safe sequence, what I think, P3, P4, P1, P2, P0. Okay, so you just find the safe sequence, and the question can be asked in university exam is that what is banker algorithm, and write down the safe sequence. And in GATE they can ask how many safe sequence do we get.